Hi everyone, welcome to the session. In this session, I'm going to discuss about the lab of Azure Load Balancer. This session is the continuation of our last series, the load balancing solutions. Let me just give you the overview first, then we will jump to the practical. We were discussing about the load balancing solutions that we have in Azure. So, the first load balancing solution in Azure is Azure Load Balancer. Then we have application gateway. Then we have traffic manager. Then we have front door or CDN profiles. So we were discussing about the Azure Load Balancer. I have one video where I was discussing about the Azure Load Balancer concept, why it is needed, what does it do. So in this series, I will be focusing on the practical part. So in case you don't know what is Azure Load Balancer, you can refer my last video in the playlist. So let's get started. In order to do the practical of Azure Load Balancer, what infrastructure we need to create? So I will be creating two virtual machines. Let me just write it down here. So in terms of setup, in the Azure portal, I will be taking two virtual machines in Azure. They will be Windows based. You can use the Linux virtual machines as well. You can use the Windows virtual machine as well. So I will be using the Windows virtual machine here. So I will create two VMs in Azure. Right after that, I will install the IIS server over there. So I have to install the IIS role, which is Internet Information Services in Windows. This service or role will help you to create the web servers inside these VMs. Because in our load balancing setup, what I'm going to do, so I will be setting up two VMs. You can have multiple VMs, but two VMs are okay for this practical. Then I will set up the Azure Load Balancer and I will connect these two virtual machines with the Azure Load Balancer as a backend pool. So you know what is backend pool? Backend pool are the servers which is connected with the Azure Load Balancer. So this is my Azure Load Balancer and these two are my backend pools. So now what I will be doing, I will be setting up here web server. So this will be my web server and this will also be my web server, and I will install the IIS role in order to create the web server. So when you are using the Windows Server operating system, in order to set up the web server, you have to install the IIS role. And when you are using the Linux, so there you will be having Nginx and Apache services for creating the web servers. Since I'm using the Windows Server over here, so I will be installing the IIS role. After the IIS role has been installed, I will configure the web pages over here. So that will be a normal web pages. In the production scenarios, there will be the real code of the web application, which will be set up over here. Then we will connect these two servers with the load balancer, and then I will show you the load balancing. So we will send the request to the load balancer for connecting with the web applications or the website. Then the load balancer will route that request to any of the available backend pool. Maybe this one, maybe this one, depends upon the availability. So we will see this. And apart from that, in the load balancer, we will further see some more practicals. But first of all, let's set up two virtual machines. Then we will install the IIS server. Then I will set up two different web pages. I will set up two different web pages on these two web servers. Why I will set up two different web pages? Because I want to show you the outcome, that whether the load balancing is actually happening or not. But in the company scenario, there will be same web pages configured on both the virtual machines. But here for the practical, just that you can understand the real outcome, I will be using two different web pages. Then I will set up the load balancer. So right after this, I will set up the load balancer. So let's first set up these configurations. Then we will jump to the load balancer setup. So I will go to my Azure portal now. And here, let me first create two virtual machines based on Windows. So I will quickly go to the virtual machine section, and from here, just click on create, then virtual machine. So here I will create a resource group because I don't have any free resource group as of now. And this VM name will be web server -01. So I'm going to set this up as a web server 01, and this will be there in the UK South region, and I will not make it as part of any availability. So this will be the isolated VM. And in terms of image, you can pick any of the Windows server. I will choose Windows Server 2019, which is around 2 CPUs and 8 GB of RAM is fine for this practical. Then I will set up the username and password of the admin account. Now in the inbound port rules, because I want to configure this server as a web server, so we have to enable the HTTP and HTTPS ports as well. So now, in case your web application or website is hosted on HTTP, then you have to enable port number 80. In case it is hosted on HTTPS, then you have to enable port number 443. In case your web server has the combination of web applications or websites, maybe you have uh, some applications running on HTTPS, some applications are running on HTTP, then you can enable both the checkboxes as well. In this practical, I will be using the HTTP web page because in order to use the HTTPS, we must have the SSL certificate with us. So I don't have any SSL certificate as of now, so I will be using HTTP only. But for in case there is HTTPS website or HTTPS web application, you can enable this. And even if you forget to enable any of these, you can also do it later on. After the deployment, using the NSG rules, you can still enable these ports. Or if you want to disable them in future, that is also doable. So RDP has to be enabled for the remote access, and I will enable the HTTP for the site. Even if you check both the boxes, that is also fine. But I don't want to allow HTTPS because we want to practice the security feature as well. So it is not a good idea that if you are not using HTTPS, so enable this port. It's not a good security practice. So I will go with the HTTP only. Click on next. I don't want to add any extra disk. Next. In terms of virtual network, I will just change the name of the VNet. So I will give the name as VNet-01. Ranges are okay for me. Subnet name, here I will just make an edit and I will change the name as subnet 01. Yeah. So rest of the things are fine. It is going to take B class of IP. Okay, good. So rest of the things will be okay. Click on next, 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 and review plus create. Let's click on create and let's wait for the deployment to be completed. So my first VM has been deployed. Now, if you go to the virtual machine, so you will see the first VM is ready. Now I have to deploy the second VM as well because I want to create two virtual machines. So let's go and create the second VM. It will be in the same resource group and the name I will give is web server -02. So it will also be independent. If you want, you can make it as part of any availability solutions like AS, AJ, or VMSS, whatever. And last time I also told you that load balancer can also support the VMs, which is the part of virtual machine scale sets in the backend pool. So if you have any VM which is the part of VMSS, you can still add them to the load balancer. So this is one of the scenario based thing that you should know. So I will choose the Windows server. I will go with this configuration. Then let's set up the user ID and password. Now here as well, I will enable the port number 80 for HTTP. Click on next. Next, I want to add this virtual machine in the same virtual network. So I will be choosing the VNet 01, where my first web server 01 is also connected. So the network has to be same here. Then I will be choosing the same subnet 01. The rest of the configurations are okay for me. Click on next, next, and review plus create. So this deployment is also completed. Now if I go to my virtual machine, so here you can see we have two VMs ready. Now I will take the remote of these two virtual machines and let's configure the IIS role. So we have to install the IIS role inside these two virtual machines. Then we will configure two different web pages. So this part is completed. Now let's jump to the IIS server installation. So I will take the remote of both the servers. So just connect. I will download the file. Let me refresh the browser once. So here I will enter the password. So this VM is connected. Now let me take the remote of the second VM as well. So I will just go to the second VM and let me download the RDP file here as well. Let's connect. Now I have two connections ready, so let's wait for these servers to get sync. Then I will install the IIS role over here. So as we know that whenever we will log in into the Windows-based virtual machine, if it is Windows server, then automatically it will open one of the server manager. So from here we will install the IIS role. So server manager will be automatically open when you will log in into the Windows server. But in case if you have closed it, then what you can do, you can just click on Windows button and you can go to the server manager from here. So you need to go to the server manager for the IIS role configuration, and here as well you will see that server manager has been automatically open. So what we have to do is we have to just click on add roles and features, but right now it is in the sync mode, so you can see some blue lines are going on. So this is the refresh symbol. Now the refresh is done. You can see the third tab has been added. So once the third console is added, you can just click on add roles and features. Click on next. We have to perform the role based installation. Click on next. The name of the server is web server 01. So on this server itself, I want to perform the installation. Click on next. And you will see a lot of roles over here. So what we want to install is we want to install the web server IIS. So we can check this box. And along with the web server IIS, it will also install some of the dependent services. Like in order to manage the IIS server, it will install the management console. So that is fine because we need it in the future. So click on add features. The box has been selected. Click on next. These are some of the features related to the Windows server and security. So we don't have to use any one of this. Just click on next. This is the description of the web server. Now we can click on next. And these are some of the services which is required to operate the web server. So we are not going to work on the web server that much because that's not our responsibility as a cloud admin. Uh, there will be separate hosting team which will be responsible for this. But for now, whatever default options are selected, let's leave them as it is and click on next, because our focus is just to run the web pages or web application on the web server. So we are not going to discuss about these services as of now. These are the server services, not the cloud services. They are related to the operating system Windows server configurations regarding the IIS. So just click on next and install. So now let's wait for the installation to be done. And meanwhile, it is happening. Let me go to another server. And here as well, I will just install the IIS role. So it is already refresh. Just click on add roles and feature. Next, next. And here as well, I will just select the box of IIS web server, add features. Next, next, and install. So let's wait for this to be completed. Then I will set up the web pages. So installation is successful on web server 01, but let's wait for the second web server 02 for the installation to be completed. Then we will configure the web pages. So let's wait for some time. Yeah, so here it is successful. Now I will go to web server 01. So this is my web server 01, as you can see. Now what I will do, so I will just close this, and here I will set up the web page. So before that, let me show you something. So if you open the server manager, once the IIS role has been installed, when you go to the tools, you will be able to see the IIS manager. So this option will only come when the IIS role has been installed. So from here, you can manage the complete configuration of your web server. So if you want to allow any kind of security, if you want to manage any kind of hosting or any stuff like pools or something, you can manage everything from here. But we will be configuring a very simple web page. So what we have to do, once the IIS role has been installed, when you go to the C drive, so you will see there will be one folder inside the C drive, which is initpub. So this initpub will be there. You have to go to the initpub. Then these are some of the subfolders where the logs will be stored for the web services, the temporary files, the history, and all the configuration related information will be here. So we need to go to the triple W root folder. We have to go here, and here you will see there will be one default page. This is one of the default page just to check whether the web server is properly working or not. So in case if you go to your laptop, and from here, if you just copy the public IP of your web server 01, because your website or your web services is running on the server directly, so you can just copy the public IP, and here if you just paste the public IP, then slash, even if you just directly press enter, you should be able to access the default web page. See, so this is the default web page, and if you are able to access this, it means your web server is properly working. So this default page is this one. This one is that default page. See, you are able to access this page from your location. So anyone who have this IP, they would be able to access this. If I right click and if I open this with the notepad, so you will be able to see this code as well. See, let it load. Yeah, so this is the code through which this particular page has been designed. So what we have to do, just leave it as it is. We have to create a notepad file in the same location. So I will just open a notepad and I will just write a very simple HTML code syntax, H1, which is heading 1. This is my web page, let's say number 1. And I will close this heading now. So if you know the coding, if you know some web development, you can use your code in your own way. But I'm using this simple syntax so that everyone can refer this. Just go to the file, save as, and we can go to the same location. Just go to the C drive, initpub, triple W root, and here I will save this file as default.html. So I'm doing the HTML coding here. It's just a simple code. Choose all files. Name of the file is default.html. You can give any name, but this is the standard. So index.html and default.html is fine. Click on save. Now you will see one more file has been created with the name of default.html. So if you just go to your laptop, even from inside the VM as well, you can access this. So just paste the public IP of your web server 01, then slash, use the name of the site, which is default.html, then enter. So you should be able to access the web page. So this is my web page that I have coded. I am successfully able to access it as well. Now what I will do the same thing on second server as well, which is my web server 02. So here the installation has been done. Just close, close. And here as well, I will open the notepad. And as I mentioned, I will be creating two different web pages. not the same. But in company, the same web application or same website will be running on all the web servers in the cluster. So here I will be using the different one so that we can see the outcome. So this is my web page number 2. Then close the heading and I will save it in the same location, file save as. Then I will go to C drive, initpub, triple w root, and here it will be with the name of default.html. All files, save, close. Now let me see if I am able to access this or not. So I will just copy the public IP of web server 02. Then slash, the name of site is default.html, enter. So this is also accessible. So I am able to access both the web pages from both the VMs. It means my web server is properly working without any issues. So this part is also completed. So now we can jump to the deployment of load balancer. So let's get started with the load balancing service now. So here I will search for the load balancer and you will see the option is here. Just click on the load balancer and you would be able to see the services which I was talking about. So we have application gateway, we have load balancer, we have Azure front door, and we have the traffic manager as well. So all these 4 load balancing solutions are available under the load balancing and content delivery feature. So we just have to choose the load balancer and you can see the description about it. Just click on create. Then there are 2 types of load balancer here. The one is standard and the another one is gateway load balancer. So what is the difference? So the difference is, let's say, if I talk about the standard load balancer, so this is my load balancer, for example, and I have 3 servers connected as a backend pool. So these 3 servers are connected with my load balancer as of now. Now, if I talk about a standard load balancer, let's say this is a standard load balancer. So if I talk about the standard load balancer, what happens if any user is requesting for any web page or any web application running on the backend pool, running on these web servers. So user will send a request to the load balancer directly. They will not hit to the web servers, as I mentioned in the previous sessions as well. So user will send a request to the load balancer. Now, load balancer will receive the incoming request from the user, and according to the rule configured, the load balancer will redirect that query to the available backend server. Maybe this server is available, so load balancer will send the request to this server and it will perform the equal load balancing as well. So that's a different story. So that kind of setup is called standard load balancer. So in the standard load balancer, when the user sends a request to the load balancer to access any web page or any web application, the load balancer will distribute that query to the available backend server depending upon the load balancing feature and depending upon the rule that we have configured. So this setup is called standard. Another setup is called gateway load balancer. So what is gateway load balancer? Let's say we have a load balancer here and I have one of the, let's say, firewall. And then I have 2 backend pools. So my backend pools are attached with the firewall. Firewall is attached, let's say, with the load balancer. And if any user wants to access any web application hosted on these 2, let's say, web servers, so user will send a request to the load balancer. Now, load balancer will receive this incoming traffic, and after that, load balancer will not distribute that query to the available backend servers. It will distribute it to the virtual appliance. So virtual appliance can be anything. Virtual appliance can be your firewall. Virtual appliance can be another server for the filtration purpose. or maybe for the compliance you have some another server where the some sort of, let's say, content filtering or antivirus is set up, and you want to scan the content before sending it to the backend pool. So that is your virtual appliance. So if you don't want to send the traffic directly to the backend pools like we did in the standard setup, you want to send it to the virtual appliance, maybe for compliance, that is it has to go through with this particular server only, because in some company there are some compliance, there are some regulations that if any user is sending a request, it has to first go through with their, let's say, local DNS, or maybe from their local RODC, the Active Directory Domain Controller. So if that kind of compliance is there, you want to send the traffic to that particular server, that is your virtual appliance, or maybe you want to send the incoming traffic first to the firewall. Let's say this is your firewall, and you want to send the traffic first to the firewall for the filtration purpose. Maybe this URL is correct or not, maybe this is legitimate or not. If it is fine, then you want to redirect them to the available servers. So if this kind of setup you have, that is your gateway load balancer. So gateway load balancer will distribute the traffic to the virtual appliance. Then after it will get transferred to another servers depending upon the requirement. So we have two categories, and we are going to use the standard load balancer here. Gateway load balancer we will discuss in the future topics. So for now, let's choose the standard load balancer. Just click on this. And now you have to choose the subscription and the resource group. So I will set this up in the pop resource group. Name of the load balancer, let's say I want to give LB-01. Region will be UK South. And in terms of SKU, I have chosen a standard load balancer. Now we have two types of load balancer, public and internal. So we will choose public here. And what is the difference? So see what happens. Let's say this is my load balancer, and this load balancer is further connected with one of the VNet. And in that VNet, let's say I have two virtual machines connected as part of the backend pool, or let's say we have three VMs connected as part of the backend pool. So this is my VM number 1, this is my VM number 2, and this is my VM number 3. And here is my load balancer. And this one is my VNet. Now, I have one more, let's say, load balancer. And with this load balancer, I have two servers connected, and these two servers are working as a SQL database. They are the databases, and they are connected with this load balancer. And this load balancer is actually connected with my internal network. So it is connected with this particular three servers as well. This is also load balancer. So the load balancer, which is directly connected with the internet, the load balancer which is directly connected with the public network, you can say, or with the internet, that is your public load balancer. So this load balancer is a public load balancer. And this load balancer will be responsible for receiving the incoming queries of the user from any location. From any location, if any user wants to, let's say, access any web application or website from these servers, so this user will request first to the load balancer. This load balancer will be connected to the internet or to the public network using the front end IP. This load balancer will be having a public IP, which is called front end IP. So using the front end public IP, this load balancer will be connected to the public network. This load balancer will receive the request of the user, and according to the rule, it will transfer it to the available member server. Let's say at a time, if three users are requesting for the web application, so one query will be transferred here, another one will be here, and the third one will be here. So there will be equal load balancing. Now, there are some requests where the database connection is also required. For example, let's say you are accessing a shopping site. You are accessing a shopping site and you are, let's say, searching for television. Let's say you are doing online shopping and you want to search for the television. So television content request will come to the public load balancer from these users. Then the load balancer will transfer it to the application server so that you can access the shopping sites. But when you will search for the television on the shopping site, so that television information, let's say, is not available with the web servers. They only have the web application to provide you. That is the shopping application. But if you want to access the television content, let's say you want to see the details of the TV, the televisions available online. So they don't have this information, but what they will do is they will transfer that information to the load balancer, which is one of the internal load balancer. Internal load balancer is a kind of load balancer which is not connected with the public network. It is connected internally in your local network, or you can say inside your VNet. So the information will be transferred to the load balancer. Then this load balancer will further transfer that information to the databases, because the databases may have those information. So the information will be, the traffic will be transferred to the database. Then the database will provide that TV content information to the user. So again, it will be private. The database server will not directly approach to the user. It will approach to the load balancer. The load balancer will further approach to the public load balancer. Then the user will be able to display the details. So the load balancer, which is used for the balancing of the databases internally, that is called internal load balancer. And internal load balancer is not connected to the internet or any public network, because they are meant for the databases, and databases has to be inside a private zone only for the security purpose. So if you have this kind of extended setup, then there will be two categories: the public load balancing service and the internal load balancing service. So as of now, we are focusing on the public load balancer as part of our curriculum, but in future there will be the advanced topics on this extended setup as well, where I will be using public plus internal architecture both. So you will get such kind of sessions in the future when I will upload the advanced series, because this series is all about Azure zero to expert. So I will take you to the expertise level. For now, let's focus on the public. Then we will further understand the internal services in the upcoming lectures. So I will choose here public, then the tiers. So we have two tiers, regional and global. If you choose the regional, so regional load balancer is meant for the regional location. Let's say I have a load balancer and I have two servers as part of the backend pool. So these two servers are, let's say, in the UK South. And if you want to connect them with the load balancer, your load balancer should also be under the UK South. So your load balancer region and your backend pool servers region should be same if you choose the regional load balancer. There is furthermore setup which is called global load balancer. So in the global load balancer, what happens? Let's say you have a load balancer and this load balancer is in East US location. Then you have again further three more load balancers. The second load balancer, the third load balancer, and the fourth load balancer. So there is a load balancer in the East US. Then you have again three further load balancer. This one is in UK South. This one is in India. And this load balancer is, let's say, in West Europe. And here their backend pools are connected. So here we have, let's say, two servers connected. Here as well, we have two servers connected. And here, let's say, we have two servers connected. Now, this architecture is called global load balancing architecture, or you can also call it cross zone load balancing. So what is the meaning of this? If any user, let's say here is a user and he is based in India. So from here, he is sending the request to the primary load balancer for accessing any web application. So it will go to the primary load balancer, and let's say it is in the East US region. So this load balancer will see that from where the request is coming from. So in our case, the request is coming from India. India is the source here. So this load balancer will see that where should I redirect this query, because this user is coming from India. So load balancer will figure out that which load balancer is near to the India, which will be able to handle this request. So luckily we have one load balancer which is in India itself. So this load balancer will route this user to this particular India load balancer. And now this India load balancer will route the request to the available backend pool. And this user will get the response accordingly. If let's say there is a user which is coming out from any other country which is not mentioned in our load balancers, still the load balancer will figure out that which load balancer is nearby to that particular region, and accordingly it will get transferred. So this is how the global load balancer or cross zone load balancer setup works. So I will also show you this practical in the future sessions. This will be again the part of our series. But for now, let's choose the regional load balancer. Then click on next. So load balancers requires a public IP in order to connect with the public network. So if you want to connect your load balancer with the public network, and of course we need it because this is going to become a public load balancer. User can come from any location for accessing the service. So load balancer requires a public IP in order to connect with the public network, and that public IP is called front end IP. So we have to add a public IP here. So if you have free IP, you can. Otherwise, click on add a front-end IP configuration. These IPs or these configurations can be done after the deployment as well. So if you want to do it after deployment, you can. If you want to make any changes, you can also do it. But I will add it right now. So add a front-end IP and just give the name of a front-end IP. So I will give FIP-LB-01. Then I will be using IP version 4. Then I don't have any free public IP, so I will create a new. So I will give the name PIPLB. So this is the name of my front end, and this will be the name of my public IP. So PIPLB, then save. I am not using any gateway load balancer as of now, so it will be none. Click on save. So front end IP will be created after the deployment. Click on next. Now you can add the backend pool. Backend pool means the servers which will be connected with the load balancer for the purpose of load balancing. So in my case, I have two VMs, the web server 01 and web server 02, and I want to add both of them as part of the backend pool. So I will add them, and in future, if you want to add more servers, you can also do it. If you want to remove any particular server, you can also do it. So add a backend pool. Give the backend pool name. I will give BP-01, in which VNet your VMs are available. So my VMs are available in VNet 01. Then I will click on add, and it will show you the server details. So in VNet 01, we have two VMs available, web server 01 and web server 02. See? So we have two VMs available, and they both are connected in the same virtual network. See? With VNet 01, both the servers are connected here. See? So they have their private IP over here. I want to add both of them. So just choose both of them and add. So load balancer does not understand the public IP of the VMs. It will only understand the private IP. So two VMs have been added. Now click on save. So backend pools have been added. If you want to add more backend pools, you can also do it. Now click on next. So here there are some settings related to the rules and everything. You can also set this up later on. So I will show you this one later on. For now, just let's click on next. There is one option, outbound rule, which we will discuss. For now, let's leave it as it is. Next, if you want to add some tags, you can. Otherwise, next. And click on create. So it is running the validation for now. Now click on create. So let's wait for this deployment to be completed. So this deployment is done. You can see the load balancer has been set up. And if you see the deployment details, so it has updated the two network interface card because two servers have been added as a backend pool. So two NICs of the servers have been updated. One of the load balancer has been created, and one of the front end public IP of the load balancer is created. If you now go and search for the load balancer, so you will see I have LB-01. If you open this, so you would be able to see the details. So it is connected with the backend pool with the name of BP01. We have not set up any rule. We have not set up any health probe. Then there is no rules configured. On the left side, if you go to the settings, you will see the front end IP. So using this front end public IP, my load balancer is connected with the public network. So this is one of the public IP. If you want to add more public IPs as a front end, you can also do it. In the backend pools, you can see two servers are connected as part of the backend pool. And if you want to add more servers, you can also do it. So both of them are in the running condition as of now. So servers are okay. Now, there are some components of the load balancer that you need to know for the work and the interview purpose. It is very important to know the components. So the first component of the load balancer is front-end IP. Second component of the load balancer is backend IP, or you can say backend pool. Sorry, not backend IP. It will be backend pool. Then the load balancing rules and the health prop. So these are the important components of the load balancer, which is important and required. So you have to remember this for your interviews and for your daily routine job regarding the load balancing services as well. So what is front-end IP? So using the front-end IP, let's say this is my load balancer, and I have one, two, and three servers connected as part of the backend pool. So this is my backend pool. This is my load balancer. So front-end IP, as I told you, is the IP which will be connected on the load balancer, using which the load balancer will get connected to the public network. So front-end IP is like a public IP which helps the load balancer to connect with the public network. Backend pool, backend pools are the VMs or the servers which is connected with the load balancer for the purpose of load balancing. Then we have to set up the load balancing rules. So load balancing rules will be set up on the load balancer itself, and these rules will decide that how the load balancing will happen. If any user is sending a request to the load balancer regarding any web application access or regarding any website access, so how the load balancer is going to take that incoming request and how it will be routed to the servers in the backend, that will be decided through the load balancing rules. So rules will decide that how the user's query will be transferred to the backend servers for the purpose of load balancing. So we will configure this load balancing rule as well. Load balancer itself does not do any load balancing. We have to set up the rules so that the load balancing can happen. Then we have the health probe. So health probe is also configured on the load balancer, and the job of the health probe is to check the health of all the backend servers which is connected in the backend pool. So what does it do? It will send the signal from the load balancer to the backend servers time to time. Time will be set up by you. Maybe it is 5 seconds, 10 seconds, or maybe 5 minutes. So after that particular interval, the health probe is going to send a signal to the available backend servers, and the servers will have to respond back to the load balancer. If the server sends the response back, health probe will declare that server as a healthy. It means that server is okay to accept the traffic. In case one of the server does not respond back to the health probe, maybe there is a technical fault, maybe there is some outage, maybe the server is not properly working. So if the signal does not receive on the health probe end, the health probe or the load balancer will declare that server, let's say this one, as unhealthy. So unhealthy basically means now this server will not receive any traffic from the load balancer. If any user sends any request, load balancer will ensure that do not forward the request to this particular server because this is down. So these two servers are up. So request will be forwarded to these servers in the load balancing manner. Again, because the health prop sends the signal after a particular interval, let's say we have set up 5 seconds. So after 5 seconds, the health prop will again send the signal back to all the servers, whether they are dead or active. And if this server comes back online, if this is fixed and it comes back online again, it will respond back to the health probe. Then the health probe will again declare this server as healthy or active. Then the load balancer will start sending the traffic to this server as well. So health prop plays a very, very critical role in deciding that which backend pool is healthy or not, where to route the traffic or not. So health prop will be using the TCP, UDP protocol over here for checking the health. So it will be transmission control protocol and user datagram protocol. As I mentioned in the previous lecture, the Azure Load Balancer works on layer 4 of the OSI model, which is transport layer. So on the transport layer itself, we have TCP and UDP protocol works. So TCP and UDP will be working along with the health prop to check the health of all the servers. So these are the components that you have to remember. Now let's jump to the portal again. So we have to configure the health prop. Front-end IP is already configured. Backend pools are already configured. Now we have to configure the health prop, then the load balancing rule. So I will go to the health prop now and click on add. Just give any name for the health prop. So I will give HP01. Then the protocol. So in the protocol, you have to choose TCP. In case you have only HTTP site running on your backend server, then you can choose HTTP as well. If it is HTTPS only, then choose the HTTPS. But in case both the sites are running there, maybe in your web server, you have some sort of HTTP sites and some sorts of HTTPS sites, then you can go with the TCP as well. So TCP is very generic here. So you can go with this. Then in the port, okay, I just missed to forget one more thing. So health probe will be using TCP, UDP, and for sending the health probe signals, it will be using HTTP and HTTPS in the Azure Load Balancer. Because my site can be on HTTP or it can be on HTTPS. And TCP and UDP will be responsible for sending the traffic. So you have to remember this. Now, so the port of TCP here will be 80 because my websites are running on port number 80 on HTTP. They are not HTTPS. If it is HTTPS, it will be 443. Then after how many interval, it will check the health of my backend servers after sending the signals. So minimum you can just, let's say if I try to give one, it will give me the error because minimum duration should be 5 seconds. So after 5 seconds, it will send the signal to my backend servers to check the health. Maximum it can go in this timing. It is in seconds, so you can convert it to the minutes or hours. I will give it 5 seconds. After every 5 seconds, it will check the health of all my servers. And I have two servers running as part of the backend pool. So it will check the health after every 5 seconds. Click on save. So health probe is also configured. Now I have to configure the load balancing rule. So I will go to the load balancing rule, and this rule will decide how the traffic will flow, how the actual load balancing will happen. So I will just click on add, give a name. So I will give LB rule -01 as a name. We are using IP version 4. My front end IP of the load balancer is this one. So I have chosen this. So the traffic will come to the front end IP. Then it will be routed to the backend pool 01 based on the TCP protocol. And here we have to specify the port. So if any traffic is coming for HTTP, if any request is coming for my website, which is running on port number 80, HTTP, it should be routed to the backend port 80. So if any user is requesting for the HTTP site from the source, it should be routed to the backend server on port number 80. It means the user should be getting the web page or web application. So this is the user. This is my load balancer. and these two are my backend pool. So if any user is requesting for any web service, if he wants to access any web page or any website, he will send a request. If the site is HTTP, so definitely he will send it on port number 80. If the site is HTTPS, he will send it on 443. If the site opens in HTTPS link, definitely by default it will be 443. If it opens in HTTP, it will be 80. Then the load balancer will receive the incoming request on port number 80. After that, because user is asking for the website or web application, so load balancer will also route it to the web servers in the backend. And because it is HTTP request, so the port will be 80 in the backend as well. So we have to mention 8080 in the source and destination. If it is HTTPS, then it will be 443 and 443. Which health probe will check the health of all the backend servers? So it will be HP01. Then there is an option session persistence. So session persistence are basically used to keep the history of the request which is coming from the source and which is going to the destination backend server. So it can keep the history on the basis of source IP, or it can keep the history on the basis of source IP and protocol. So this is basically used to keep the history or the cache of the source. Like if someone, let's say, is if let's say I'm the user and I want to access something from the web server, I will send my request to the load balancer. And let's suppose first time the load balancer has transferred the request to this server to process this user. Now, next time, if I will enable the session persistence, so next time when this user will send the request to the load balancer will immediately see the cache memory, the history, and earlier this user's request was routed to this particular VM. So next time also this user's request will be routed to this particular VM. So that is session persistence, and it helps to improve the performance, the minimize the latency, and sometimes due to compliance also we have to redirect the user to the same server. So in those conditions, the session persistence has to be enabled based on the source IP or based on the source IP and protocol. So we will not use it. Idle timeout means if any request does not arrive on the load balancer, then after 4 minutes it will go to the sleep just to save the cost. So that's a different story. Outbound rules we will discuss after some time. For now, whatever default is there, leave them as it is. Here it has to be 4 minimum. So I have set up all this. Now click on save. So rules are also configured. So rules are also saved. I have the rule. So I have completed all the components of the load balancer, front end, back end, LB rules, and the health prop. You can see we have the front end, we have the back end, we have the health props, and we have the load balancing rules. So all the components are done. Now my load balancer should be working fine. So what I will do is I don't need any public IP on the VMs. So I will just go to the web server 01 and 2 and I will remove their public IPs, because in the production scenario, we don't have the public IPs on the VMs. So we should not have any public IP on this server. So I will just go to web server 01, click on this public IP, go to the overview and disassociate. And I will also delete it. I don't need this further. So this is done. Now I will click on delete of this public IP. So done. Now same thing I will do for the web server 02 as well. So go to web server 02, click on the public IP and just disassociate and delete. Now delete. So this is also done. Now I don't have any public IP on my virtual machines. you will see there is same IP. There is a same public IP, and this is not the public IP of the VMs. These are the IP of my load balancer front end. See, if you go to my load balancer, if you go to settings under the front end, you can see this IP. So this is the IP of the load balancer because the load balancer is connected with these two servers as a backend pool. Even if you click on the web server 01 or any of the server here, if you try to connect, so you will notice that it is only showing you the private IP. And if you click on the drop down, it is asking you to add a public IP. So there is no public IP configured on the VM, and there is one public IP which is of the load balancer public IP. See, and you cannot use this IP to connect with the web server for the remote purpose. So now let's see how the load balancing happens. So user will send their request on the front end IP of the load balancer like this. Let me copy this IP. Let me paste it here, and let's remove these extra things. So this is the IP of the load balancer front end. Then I will use slash, and here I will mention the name of the site, default.html, enter. And let's see where does it go, in which server the request is getting routed. So you can see it is going to web page 01. This is my load balancer. I have two servers connected in the backend. On the web server 01, this is my web server 01. Here, this particular site is running. And on my web server 02, there is another site which starts with number 2. So what I will do is I will copy this URL and I will open another browser. For example, I will just open this browser, and here let me paste this address and let's try to make a new request. So it is going to the web page 01 as part of the load balancing. And what I will do again, I will again paste this URL. So here it is going to web page 01. So alternatively, all the requests here are going to web page 01 because load balancer will decide how it should go. So let's see what about this one. So it is going to number 2. See, so the requests are going to the web page 02 now. And let's see one more time. So see, this one is on number 1 and this one is on number 2. So the requests are getting routed to the backend servers in the equal manner. Some requests are getting routed to the web server 01 where this page is hosted, and some requests are getting routed to the web page 01 which is running on web server 02. So this is running on web server 02 and this one is running on web server 01. So you can see the load balancing is happening, and you can now understand why I have used the different web pages on both the servers, so that you can see the outcome, that how the requests are getting replicated. In the company, the same code of the web application will be there on all the backend servers, on all the member servers. But here, just for the reference, I have used the different codes so that you can see. Now, the load balancing is happening. Now, let me do one thing. Let's do one thing. So I will go to the portal. And here, I will go to web server 01 and let me just stop it. Let me deallocate this VM. So this VM has been stopped. Now, because we have the health prop configured, so after 5 seconds, when the health prop will send the signal, let me refresh this. And here, if you go to the health prop, so this health prop is configured. And if you go to the backend pool, so it will show you the status of one of the server which is stopped. So this status is coming because of the health prop. Because there is no issue, we have just manually stopped it. So that's why it is telling you the status has stopped and the second server is in the running state. But if there will be any issue with any of the server, let's say this server runs into any issue. So here in the resource status, it will show you the error that this server is, let's say, unhealthy. So here you will see the unhealthy state, and accordingly you can go to the server and you can fix that issue. But because this server is not healthy, it is stopped, so load balancer will not send any traffic back to this web server 01. All the traffic should be routed to web server 02 only. So let's see, this is one of the requests which got routed to web server 01 earlier. If I refresh this, so you can see it has been routed to web server 02. And similarly, all other requests, this one was already on web server 02. So this one was on web server 01. Let me refresh this. So this has also been routed to the web server 02. So now all the future requests, even the present request, will be routed and terminated to web server 02. Whatever refresh you do, it will not go back to the web server 01 because that is unhealthy. By chance, if you just turn it on back, if I start this server again, so after some time when it will come to the healthy status in the running state, then the request will start transferring to the web server 01 again. But for now, it will not route back because of the issue. So this is how the load balancing happens. So we have seen the load balancing concept. If you go to the resource visualizer, you would be able to see I have the load balancer which is connected with one of the public IP, which is the front end IP. So this particular concept is completed. We have seen the load balancer successfully. Now there are some additional options that we want to discuss in the load balancer, which is NAT rules and the outbound rules. So let's talk about them. So they are not related to the load balancer, but they are some additional options. So let's talk about NAT rules. Here, if you see under the load balancer, there is one option, inbound NAT rules. So right now, there is no public IP configured on these VMs. These are the IP of the load balancer, and using which I cannot take the remote. If I want to take the remote, I cannot. See, if I just click on connect, here is a private IP, and using the private IP, we cannot connect to the VM. We have to use the Bastion or any other option. And right now, I don't have any public IP here. Even the load balancer public IP will not allow me to take the remote. But I don't want to add any public IP on the VMs because we don't use them in the production. So I want to take the remote. And what I want to do is I want to use the load balancer front end IP to take the remote. Means when any user wants to take the remote of the VM, the request should come to the front end IP of the load balancer, which is a public IP. And through that front end IP, the request should go to the private IP of the VM. So VM will be operating on the private IP only. The private IP will get translated to the front end public IP. Then the user will be able to take the remote. So this kind of setup I want to do without adding any extra public IP. So this is possible using the inbound NAT rules. You can just go to the inbound NAT rules. Here you can just click on add, and you have to give one name. So I will give, let's say, nat -01. And there is one warning like currently the net version 1 will be retired on 30th of September 2027. So Microsoft is recommending to migrate to version 2 of the net. So that's okay. We have a lot of time. Right now we are in 2025, so that's fine. So if you want to allow the access of remote for the individual virtual machines, let's say we have two VMs in the backend pool, and you only want to allow the remote of this VM. So you will choose the Azure virtual machine. Specifically, you can define the VMs. But if you want to allow the remote of all the VMs, which is connected as a backend pool, here in our scenario, we have two VMs connected as a backend pool, then we will enable this backend pool option. So I want to give the access to the specific VM. So I will choose this. Then target VM, which VM you want to allow for the remote. So I want to allow, let's say, web server 01 only, not the 2. I will only allow web server 01. But you may try the practical to add web server 02 as well. what is the IP of this web server 01? So if you click, you will see it's 172.16.04, which is a private IP. Using which front-end IP of the load balancer you want to translate the request. So I have to choose the public IP of the load balancer. Then the port. So port. So basically this setup we are doing for the remote only. We want to take the remote of the VM. So because we are using the Windows based server, so here we have to enable the RDP, which is 3389. So if any user is requesting for the remote using the port number 3389, there should be RDP on the backend port of 3389. Means if someone is, let's say, I have this load balancer, I have two backend pools connected. If any user is requesting for the remote services using port number 3389, which is RDP port, the request comes to the load balancer. So load balancer should redirect that request to the specific server mentioned here for the remote only, for the RDP only. So it should not be for the website or web application access. It should be for the RDP only. That's why we have to enable 3389 on source and destination. And the protocol is RDP. If it is Linux, then you will enable SSH on port number 22. So in our case, it is Windows. So we will enable RDP on port number 3389. Then protocol will be TCP. So timeout, you already know. If any request is not coming, then it will be idle. Save. So it is creating the rule. So this particular rule has been set up. We have net 01. Now let's see whether I'm able to take the RDP or not. So I will just refresh this browser. Go to web server 01 because I have allowed this one only in this rule. See. And now I will try to connect with the VM. So click on connect. Then here I will just see the load balancer public IP option has been enabled. Earlier it was not highlighted. And then I will download the RDP file, keep, then open file, then connect. So using the public IP of the load balancer, you can see we are able to initiate a connection to the VM remotely. Now let me enter the password. Then yes. And here we have the remote. See, here the remote connection goes. So the remote connection is done. Now let me show you something. If I open any browser, let it refresh and let me make some browser settings. So start without data, continue, then confirm. And here if I try to access any of the site, see, means the internet. The site I mean is internet. If I try to access any of the site in internet, it will not work. See, nothing will open actually. Because when you remove the public IP from the VM, so outbound connection gets discontinue. You will not be able to connect your server to the internet. So internet connection has been restricted on this server. So the server which is connected with the load balancer as a backend pool, and if there is no public IP on the VMs or on the servers, their internets will not be available. They will not be able to connect with the public network. So their outbound connection is restricted. As you can see, the google.com is not opening up. There will be some error after some time. And if you go to the microsoft.com as well, we cannot reach out to this page. So there is some scenario where you have to provide the outbound connectivity to this VM. Means you need the internet. Maybe you want to do some patching. You have to connect with the internet for some time. Maybe you want to download something regarding patch, or you want to sync any service. So you need internet for some time. So what you can do is there is one feature which is outbound connection in the load balancer. So you can enable this option. Even in interview also they can ask you that how will you allow the internet connectivity to your server. So this is one of the answer. You can enable the outbound connection. And the second answer is using the NAT gateway also it is possible. You can configure the NAT gateway, which is a different topic. We will discuss that in future. So using the outbound connection, how to give the internet, let's see. So you can go to the load balancer and there is one option, outbound rules. Just click on this, click on add, and here just give any name. So I will give OB01. We are using IP version 4. It should, the traffic should go over the front end IP of the load balancer in order to connect with the internet. Scroll down. We want to enable the internet on backend pool 01 where we have two servers connected. Then we have to enable this option. And here we have to give the port details in the multiplication of 8. So 8 is the number that you can provide, or 16, 24, 32, whatever. So it should be in the multiplication of 8. So this is regarding the port which will be allowed in the backend for the internet connectivity. So I am giving 8 number here. Maximum you can give up to 5,000. Click on add. So it is adding the rule now. So this is also added. And now if you go to the server, let me go inside the VM. And if I refresh this, let's say this is the VM. Let me refresh now. So I should be able to reach to the internet. See, now the internet is connected. See, so this is how the outbound connection works. We are able to successfully connect with the internet now, and we are able to make the connection. Once my job is done, let's say I want to do some patching and that has been completed now. So I can just delete that particular outbound rule from here and the internet will be again disconnected. So this is also done. Now we are done with the complete topic of the load balancer. We have seen how we can set up the load balancer. We have discussed about the inbound NAT rules. We have discussed about the outbound NAT rules, which is one of the extra topic here. And if you go to the properties, you will be able to see the resource detail as well. So for now, let's wrap up this session. In the future topics, definitely we will be discussing about the internal load balancer, but that will be our future topic. We will be discussing about the cross zone and gateway load balancer as the advanced topic. But for now, you can practice this one. And in case of any queries, you can drop me the email or you can just drop me a message in the comment box regarding any queries that you have. So in case you are okay with this concept, if you are understanding everything, you can just hit the subscribe button and press the bell icon for the notification of this video. So for now, let's wrap up this call. So thank you very much for your precious timing. See you in the next session. Bye.